This video is about simplifying rational expressions, and I'm going to follow a two-step process to do this. First step being to factor everything completely, and the second step being to cross out matching factors on opposite levels. And we'll see these come to life with some examples here. So let's start with an example that looks like this. Let's say we had x minus 9 over 3x minus 27. And in this case, if I follow step 1 to factor everything completely, you can see the numerator already is in factored form. There's nothing else we couldn't do with it. But the denominator can be factored. So what I'll say is that this is equal to still just x minus 9 above. But then I can take a common factor of 3 and divide both those terms by it to get x minus 9. In other words, this expression is now equivalent to the original, but now the denominator is factored. And as you'll notice, the numerator could be put in parentheses because there are no other factors beside the x minus 9. It's just that alone. And then to show why this all works at the last step, I want to rewrite this as 1/3, okay? Because really I could even add a constant of 1 in front here. It wouldn't change or affect anything. But now you can see the 1/3 that's there, and that's really being multiplied by x minus 9 over x minus 9. Okay, using multiplication rules, these are equivalent. And of course, any expression over itself can be simplified to 1. In other words, 1/3 times 1 is what we have, which is really just 1/3. So this would be the simplified form of that original rational expression. Let's do another example. This time, let's say x squared plus 4x all over 4x plus 16. Well, if we follow step 1 again first, we'll say that to factor the numerator, we could take out a common factor of x. Dividing each term by x would give you x plus 4. And in the denominator, there's a common factor of 4. We can write then 4 times x plus 4. Okay, and once again, you can see common factors that match above and below, numerator and denominator. And so those can be canceled, leaving us with x over 4 as our final simplified answer. Let's do another example. This time we'll have 3y squared minus 15y all over y squared minus 3y minus 10. Once again, step 1 is always factor everything completely. One general way to know that things are not factored is that you shouldn't see any addition or subtraction that's not in parentheses. And so as you see here, these are kind of free. Could I put parentheses around the entire top and bottom? Sure, but that doesn't really do much. So we want to break these apart as we can with factoring first before we cancel anything. In other words, these y squareds cannot be canceled yet because we have not factored completely. Even though it looks like they match, they're attached still to these other terms. We have to factor first. So look at the numerator. We can factor out a 3y. That leaves us with y minus 5. And in the denominator, we have a 3-term polynomial. We can use any kind of product sum or guess and check method to factor this. For instance, two numbers that add to negative 3 and multiply to negative 10 would be negative 5 and positive 2. Okay, and as you can see, now that everything is factored completely, all the addition and subtraction signs are now contained within parentheses. We do have a common factor, the y minus 5 on top and bottom. Therefore, those could be canceled, and what we're left with would be our response or our answer, 3y over y plus 2. Let's do another example. This time we'll have x cubed minus 1 over x squared plus x plus 1. So this time the factoring gets a little more complicated with a difference of cubes in the numerator. In other words, this is the same as x cubed minus 1 cubed over x squared plus x plus 1. And we know that this can be factored using the difference of cubes formula as x minus 1 times x squared plus x plus 1. And if we look at the denominator, we might wonder if this is a factorable trinomial. Guess and check methods or any other product sum methods could be attempted, but probably will come up with nothing because it is a prime trinomial. But notice how it matches exactly this trinomial above. And so since all of this below, which could be considered as one large factor, matches this large factor above entirely, both of them could be canceled, leaving us just with x minus 1. Let's do another example. This time we'll use 6x squared minus 13x plus 6 all over 3x squared plus x minus 2. And so step one being to factor everything, we'll go ahead and do that. Several different methods could be used to factor trinomials like this. Perhaps a trial and error or guess and check, or some kind of AC method or product and sum method. There are many options out there. This numerator should factor into 2x minus 3 times 3x minus 2. And the denominator should factor into 3x minus 2 times x plus 1. And now that everything's factored completely, and again we know that because no plus or minus signs are outside of parentheses, we've got them around everything, then we can cancel matching factors, which in this case are the 3x minus 2 factors. The result then, of course, would be 2x minus 3 over x plus 1.